Hello, my dear students. I hope your exams are doing well. Which, you know what, I don't hope. I actually know your exams are doing well. And even if one or two papers were not exactly how you hoped they would go, I would say world is not ended. You have science paper yet, right? And you have prepared well for this. See, we have been watching each other for quite a long time. I know what you have been doing. I know how you have been doing. And yes, it's not just me, it's bio, it's chemistry also, right? So we have full trust in you. But I understand in physics there is this one small thing which I have observed has bothered you for quite a long time. See, in many sessions we have tried this small confusion from your mind to take out, that was about heating effect of electric current, right? Which formula to use? Sir, should I use VIT? Should I use I square RT? Should I use V square upon RT? And we have done multiple sessions on this, I'm telling you. So those session links are there in the description. But today, what I'm about to do is, in this whole journey, we have covered a lot of questions about heating effect of electric current. And today, we have handpicked 4 of them. And the reason of handpicking those 4 is because these 4, in my opinion, are one of the difficult or the most difficult questions possible to come in your exam. If you master these questions, means you are sorted, I would say, right? So what I want is you to listen very carefully, right? It's okay, I understand we have less time, so I'll keep it short, I'll keep it crisp. But I want is you should be ready with your notebook, with your pen, with the concepts in your head, with some confidence, with some patience, and chill, relax. You got it. Just try these questions with me, and you know what? You'll be sorted. This fear of heating effect will be gone. Fine, let's start. Let's start with the final revision of heating effect of electric current for term 2. Final, guys. This is the final thing, right? Come on, let's start. The first question. An electric heater connected to a 220 volt source uses a coil of 24 ohm resistance. All right. I don't know how many of you remember this question before, right? We have done this question. There was some glitches, there was some confusions I saw back then when this question came in front of you first. Don't worry. Come on. If you remember this question, well and good. If you don't, I would say it's better. It's a fresh question for you. You can try it, right? So, come on. Another coil of same resistance needs to be connected with the first coil in order to increase the amount of heat produced. What is given to you? 220 volt is given to you, right? There is one coil of 24 ohm given to you. Another coil of same resistance. Whenever you see such kind of questions now, and especially for term 2, I'm saying, have a habit to read the question patiently. Mark the important keywords. Which keyword is trying to give you what kind of a hint? Here, if you see, another coil of same resistance means how much? Quantify it, right? Don't just leave it like this. Another coil of 24 ohms again, all right? Needs to be connected with the first coil in order to increase the amount of heat produced. Okay, here the question has left some open-ended questions. To increase the amount of heat produced. Fine. How will you connect the coils? First, 2 connections, in series or parallel, such that the heater produces the maximum heat. And why? You got it? So this question is asking you, everything. How do you want to connect it? Why do you want to connect it, right? So that's why. If you figure out these 2 things, means your concepts are sorted. Fine. Let's see. And second part we'll deal. That's what we do, right? We break the questions part by part. And that's how we solve it. And that's how you are supposed to solve it in exams. Fine. So let's see. The first part, how will you connect the coils? So, series or parallel? What do you think? Series or parallel? See, the formula you want to use is V square upon RT. Now there comes the first question, sir. Why only this formula, right? It's okay. We have been given one coil as 24 ohms. Voltage is given to 20 volts. One more coil is there. This is of 24 ohms again. How should I connect them such that heat dissipated will be maximum? Okay. Now think, come on. Why I'm using this formula? Sir, why not I square RT? Why not VIT? Why? See, total heat produced we are talking about, right? Whatever connection you do, I'm sure, whatever connection you do, maybe this or maybe this. We are talking about total heat produced, right? Total heat. Whatever connection you do, the total voltage drop would be how much? 220 volt, right? This 220 volt will be the total voltage drop on the combination. So this question, tacitly is talking about The total heat means equivalent resistance somehow, right? So understand this thing. Don't fall into this trap of which formula to use. Think about what is easiest for me to find. Easiest for you to find is the voltage drop, which is common for both, right? Equivalent resistance. That's why we are going with V square upon RT. Fine. All right. If you figure out this much, rest is piece of cake, I would say. Come on, let's see. Two connections possible, series or parallel. All right. In series, resistance adds up. It will be 2R. In parallel, equal resistance in parallel. What happens? You have two resistance. Means you say if n resistance, so you say R by n. If two resistance, you say R by 2. Simple, right? So that's why. Now, heat produced in the series connection would be V square upon 2R into T. Simple thing, no? Here it will be R by 2. It will be V square upon R by 2 into T. Now, watch something. Just notice something. Numerator is same for both, right? If you see here, it's V square T. If you see here, it's V square T. Now, if you want the overall thing to be big, what do you want about denominator? It should be less or more? It should be less, definitely, right? Which one is lesser? 2R or R by 2? It's R by 2, simple, right? 100 or 50? It's 50, right? So that's why the answer would be this one. The parallel connection will give you more heat. And that's what you will write in exam. And you will write in style. You won't just write stories, fine. That's what we have discussed. Come on, be on the same page on this. Parallel connection of coils will produce maximum heat. Heat produced H equals V square upon R into T. And as the operating voltage remains the same, heat produced in given time will be maximum. So till here you have just repeated questions language, nothing else, right? If from here your answer starts, the equivalent resistance of the coils is minimum, and parallel combination of coils give the minimum equivalent resistance. And you know what? If you feel confident enough, I would say write this thing, V square by 2R into T. That is the series combination thing. And V square into T upon R by 2. That is the parallel thing. You can just say this one is greater. Simple, right? Okay, fine. Next, calculate the maximum heat produced in 10 seconds using the two coil. Now, you have actually given values this time. Simple, right? You have said parallel will give you more heat. Now they have given you time also. You have just to do maths. Physics is not there in this question. It's only math. Fine. Operating voltage is 220 volts. Each coil is 24 ohms. Time is 10 seconds. And this is the formula we are supposed to use. All right. Fine. So, parallel connection, voltage, put the values and get the answer. See, I'm not here to do maths for you, right? Let's be very clear over here. Maths is your department now. Paper is over. Do it. 40.3 kilojoules, V square upon R by 2 into T. This is done. Simple, right? Okay. So that's why you will write the answer as. What I'm trying to tell you here is, write the formula first, then tell what values are given to you, right? Or you can do what is given to you, then write the formula and then compute it, right? Put the values, get the answer. That's what a good student writes answer like this, right? Fine. Okay. Let's see. Next question. Feeling confident enough? First question done. Okay. Compare the power used in 2 ohm resistors in each of the following circuits. You have been given 2 circuits. What do you observe in this? There are 2 resistances, 1 ohm and 2 ohm. And second one, 1 ohm and 2 ohm are in parallel, right? Both have voltage. No. It's different, right? First one has 6 volts. This one has 4 volts. All right. Okay. Then what is asked? Compare the power used in 2 ohm resistors. A specific resistor is mentioned. It's not the game of equivalent resistance now. You have to be specific now, right? This particular resistor, which 2 ohm. Find the formula you are looking for. Think, come on. Formula would be. Now the confusion begins, no? In series, so we have always used I square R. In parallel, we have used V square upon R. But not sure why. Don't worry, I'll tell you. See, formula, you will use I square R or V square upon R. You have two formulas, right? VIT, I would say it's highly unlikely. Question if gives you voltage is this much, current is this much, right? And time is this much. Then you find the heat, or if voltage and current is given. But it doesn't actually happen. If given, good, it's a simple question. But here you have to think. You have 2 formulas. You can use any one of them depending on your convenience, depending on how confident you are, depending on how quickly you understand the question, I would say, right? So let's see. In the first question, where I'm taking you is, I'm saying in first question, look for I square RT. Why, sir? Okay, okay, it's okay. I'll tell you. I equals V upon R equivalent. Fine. In series, what is common for both? It doesn't matter what are two resistances, right? What remains common is the current, right? It flows same for both. That's why you have got one common thing, right? Why not exploit that common thing, the current? So I equals V upon R equivalent. What is R equivalent? It's 3 ohm, means current. You don't have to calculate things for this. It's so simple. Like 2 plus 1 is 3 and 6 volts, so 6.3 is 2 amperes. So you got the current is 2 amperes, right? Fine. So P will be I square R, means 2 square into 2. Got the answer, right? So what if I want to use V square upon RT? See, you can. I'm not saying you can't. But for that, what you have to do is, you will have to anyways find current, because you are trying to find the voltage drop on this 2 ohm resistor. Don't be misguided by this word V. V means potential drop on that particular resistor, right? So we are talking about this 2 ohm resistor. If you want to find the voltage drop on this, means current you have to anyways find. That is 2 amperes. You have already found 2 amperes. You will say 2 multiplied by 2. So voltage drop is how much? 4 volts. Okay, fine. 4 volts you got. Now you can use V square upon R. Not a problem. 4 square is 16 and upon R, right? R is 2. So here you got 8. Here you got 8. Got the same answer. Feeling good, huh? But the problem is, you wasted time in doing the second one. So that's why. Again and again I'm trying to say, be smart about it. Think what will give me the answer quickly. What will give me the answer easily. Here, current will give you the answer easily. That's important. Fine. Okay, next one. Next one you have to find for 2 ohms again. What if? What formula should we use now? In the first one, series, what was common? Current was common. In parallel, what is common? It's voltage, right? This much understanding we all have. In parallel, what remains same? It's the voltage. Fine. 2 ohm is also getting 4 volts. 1 ohm is also getting 4 volts. Why? Because both of them are in parallel. That's why. So what you can do? Simply you have to find the power used in 2 ohm resistor, voltage you have, resistance you have, formula you have. What's left? Calculation. That's why. Got it? So what if I want to use I square R? You can. See, in the first one I showed you. If you want to use V square upon R in the series one, you can, but V is voltage drop. In the second one, if you want to use I square R, you can, but you want current flowing in the 2 ohm resistors branch. Fine. Got it. This much conceptual clarity is very much necessary. I'm telling you, right? Okay. So that's why. First case, resistance, you find current is 2 amperes, 8 watt. We did that. Second one, it's V square upon R. V is 4 volts. 4 square upon 2, it's 8 watt. Power consumed by 2 ohm resistors is both circuits are same. I mean, luckily you found it same. All right. So don't just shoot arrows in the dark in exam. Fine. Calculate it. Be confident about it. Fine. Okay. Next question. 2 lamps. Getting it now? Feeling good? Nice. 2 lamps, one rated 220 volts, 50 watts, and another rated 220 volts and 100 watts are connected in series with mains of voltage 220 volts. Okay. What is given to you? Power ratings are given to you. All right. Fine. And what is one more thing given to you? What is the supply voltage, right? So you have 2 lamps of these and these power ratings, and this is the supply, the main supply given to them. Which lamp will glow brighter? This is another set of problems which, a lot of students have struggled with. Who will glow brighter? How would I know? You know. Don't think of brightness as your criteria. Don't think of how to find brightness. Think of what judges how bright something will glow. What is that quantity? Think, come on. We have done this multiple times. What is that quantity? It is power, right? Power tells you which bulb will glow brighter. Fine. So which lamp will glow brighter? If you are able to figure out which has more power dissipation, means that will glow brighter. Oh, sir, it means 100 watt. Huh? Hold on. I'm saying power dissipation in the current situation. It's not what is the power rating. Power rating is not always what is being dissipated right now. Look at the connection also. No? It's series. So let's start solving this question. Which lamp will glow brighter? Explain the reason. So I would say this is the main supply. And that's what the circuit is looking like. You have 50 watt to 20 volts, 100 watt to 20 volts. Fine. So think of one more thing. You want to find power dissipated. Both of them are in series. Now for you, actually, they are not like bulbs anymore. For you, it's like the question we did before. It's a 220 volt supply. And you have two resistances in series. Simple. This is the simplest version of this question you can think of. 220 volts and then two resistances, R1 and R2. I don't know which one is R and R2. That you have to figure out. How? Power rating. Simple, right? So let's see. The formula used should be I square R because they are in series. If you find current is same for both. That's why it will tell you first or quickly which one will have more power dissipation. All right. The formula used for resistance would be V square upon P. Sir, this one, which one? So you are trying to find resistance. See, from power rating, whenever you want to think of anything, power rating will tell you two things. What is the current requirement for that? Which I would say it's not necessary for this question. And what is the resistance? You have simplified your circuit to be like two resistances. What is the value? Who will tell this to you? The power rating will tell this to you, right? This 50 watt and 220 volt can give you the value of resistance. And that's what is required. Because if you get those values, you will have these two. And then, it's more or less like the last question. Simple. Okay, let's see. How will you answer first of all? Lamp that consumes more power will glow brighter. Means whoever has I square value more will glow brighter. Now, both of them are in series. Means current is same. Who will judge it now? Resistance. Okay. Let's see which one has more resistance. And who will tell it to you? V square upon P. Simple. Just discussed. For a series connection, the lamp of higher resistance will consume more power. Since power and voltage ratings of lamps are given, their resistance can be calculated by R equals V square upon P. Okay. V square upon P. If you remember, both these bulbs had 220 volt, 50 watt and 100 watt, right? Means V square is same. Whichever has lesser power will have more resistance. Whichever has higher power will have less resistance. Fine. So the 50 watt lamp will have higher resistance than the 100 volt lamp for the same voltage rating. And it will consume more power. Hence, a 50 watt lamp will glow brighter. Got it? I'm not saying more and more question solving will not help you out. It's you solve few questions, but you understand those questions in and out. That is what makes a difference between an average kind of a student and a good student, right? So think in terms of how to solve a question. What could be the methodologies? Where am I doing wrong? And if you want to go for alternate method, do it, in your free time while practicing, not in the exam. But understand the concept, right? Fine, easy question, simple question. Okay, first part is done. Second part is calculate the total power consumed by both the lamps. Now, the question has changed a little bit. Total power. Okay. So I can use I square R. You can actually see. You will get the correct answer. You have found R1, R2, right? If you want to find R1, R2, you got 220 volts the main supply also. You can find the current and then say I square into R1 plus R2. That can be done. But you know what? 220 volt of the main supply. It's a series circuit. Overall, total drop in this equivalent resistance of the combination of these two resistances will be 220 volts. So that's why voltage is given to you. Again, what is helping you out? To figure out how to find quickly, the answer quickly, right? So that's why V square upon R. Formula used R equals V square upon P. So you will find R equivalent. You found R equivalent R1 plus R2. Okay. So how will you find it? For the first one, it's V square upon P1. For the second one, it's V square upon P2. And if you solve it, simple maths, you get 1452 ohms, right? Or 1450 ohms. Fine. You got the resistance. Do you want to find current? See, you can. I just told you, you can find the current. And then again, you have to do I square into R. But I'm saying if you found the equivalent resistance and you know the total voltage drop, because we are talking about total power consumed, means you are looking for total voltage drop. For whatever combination you are trying to find the power consumed now, think of voltage drop on that segment. Here it is 2. It's equivalent. So that's why. Fine, you found R equivalent. Means you can use 220 volts main supply and divide by the resistance. No, simply this much. And you'll get the answer as 33.33 watts. Okay, got the idea? Fine. So, and that's how you will write the answer for this question. Okay, let's see, part C. What is the cost of energy to operate the lamps for 30 days at rupees 6.50 per kilowatt hour? What is the commercial rate of energy? It's kilowatt hour, right? You know that. It's a revision thing I'm just doing, okay? If they're operated for 6 hours per day, all right. So this is, I would say in heating effective electric current, this is one more type of question, costing. If I use this particular thing or this particular bulb or this particular device for such and such time, then find how much bill you have to pay, how many units came. So this is a category of questions, and this particular question is taking care of all of that. So focus here. What is the cost of energy to operate the lamps for 30 days at rupees 6.50 per kilowatt hour if they are operated for 6 hours per day? I understand. If you read this statement together, it looks like a lot of information. Break it down. Cost of energy you have to find. Okay, who gives me cost of energy? If I take number of units, means number of kilowatt hours, and multiply it with the cost per, cost how much is for per kilowatt hour, you'll get the cost, right? Okay. How much duration is given to you? 30 days. All right, at rupees 6.50 per kilowatt hour. This is the cost given to you if they're operated for 6 hours per day. So you have to find total energy consumed, right? Come on, it's easy question. Just hold on and just see how to solve such a question. Power consumed would be 33.33. You just found it, right? The total power consumed, right? This is per second. Energy consumed per second. Okay. Energy consumed in one day, the power into the time, fine. Okay, and you are trying to find in kilowatt hour. Just make sure, don't go for joules, fine. Okay, then you have to do the another conversion thing. So power into time, you have 33.33 watts multiplied by 6 hours. You get the answer and convert it into kilowatt hour. This is the energy consumption. These many units you are getting in one day. Now, how many days you are operating it? 30 days, right? That's why in 30 days, you will multiply 0.2 kilowatt hour multiplied by 30. See, it's addition only. This is energy you are consuming, you are using, right? So that's why you will multiply it with 30, you will get 6 kilowatt hour. So basically, in 1 month, if tomorrow someone asks you how many units of electricity you consume, you would say 6 units. Why? Because 1 unit is 1 kilowatt hour. That's why 6 units, 6 kilowatt hour. Now the cost is 6.50 per kilowatt hour. I mean, it's a good cost, right? So that's why it'll be 6.50. 6 into 6.50, you get 39 rupees. It is cheap, huh? It's okay. Let's live at this place. Fine, we got 39 rupees. All right. So that's how you will solve this question. You broke this question. Energy consumed, first of all, power is giving you energy consumed per second. You have to find, first of all, in 1 hour. That is watt hour. Convert it to kilowatt hour. Then see in 30 days how much energy you have consumed. And then number of units multiply with cost. Simple. I would say, a difficult question than this, it's almost impossible. Fine. So practice this question. Very important. Okay. How to write the answer? Simple. Whatever we just discussed, put it down nicely, neatly, and put down formulas. I would say don't just make up a mess. Rough work is on this side, not on this side. This is for proper answer writing. Okay, don't do that kind of mistake. Make the life of examiner easy, guys. They are also checking so many copies in one day. Make the life easier. Good answers would make sense. Fine. Come on. Last question. Calculate the amount of heat dissipated in 10 seconds by a 40 watt, 100 watt bulb when connected as shown in the figure. Heat dissipated. Looks easy, no? I mean, 50 volt and 100 volt. Normally, if this would have been 100 volts, if this would have been 100 volts, your life would have been much easier than what it is right now. I mean, 100 volts was given to you. 100 volts, it is requirement, means it will do 40 watts if it was 100 volts, but it is not. So that's why you are not that lucky. What you'll do? You'll solve it, right? So how to go for it? When connected as shown in the figure, power rating is given to you, means formula will be V square upon R, right? Which means you can use heat dissipation as V square upon R into T. Fine. Correct. All right. All right. So what do we have? We have the power rating. And I told you before, power rating is very much good to find the resistance, because once you find the resistance, no, forget about the power rating. Only think of the main supply. Main supply and a resistance, right? That bulb sometimes gives you confusions, right? So power rating, find the resistance, and replace the whole circuit with just a resistance and the main supply. You will forget that this resistance had some power rating. Fine. So do it like this. Power rating is 40 watt, 100 volts. Time is 10 seconds. The power formula is V square upon R. Find the resistance, get it at 250 ohms, and then find the heat dissipated. Right? Now the circuit is simple. It's like a 250 ohm resistance, and the voltage supply is how much? 50 volts. And if I had given you this question and asked you how much is the heat dissipated in 10 seconds, you wouldn't have taken time. Simple. But the power rating was something which was getting you confused, right? Find the resistance. That's it. So you will find the heat dissipation as V square upon R. 50 into 50 upon 250 into 10 is 100 joules. And that's how you were supposed to solve this question. All right. These 4 questions, I would say they are my benchmark to make you understand that nothing difficult can come apart from these 4 questions, right? This is the final revision, guys. And that's why I'm saying focus. If you want, do these questions separately also. Very important. Very, very important. And you got that. After that, I would say heating effect will not trouble you anymore. And rest, don't worry, we are there. We'll take care of it. All right. We have got you covered. We are trying to get you covered. That's what we do. Right. Okay. You know that. And like, share, subscribe. In few days, you'll reach a new class. Just give this exam. That's it. Right. So all the best, guys, for your exam. Do it well. And I'm sure you'll make all of us proud. Thank you for joining. Take care.